Hello, hello. Today I'm doing a live stream to play around with GPT-5, the new model family that came out yesterday from OpenAI. It's a pretty exciting new model. It's got some clear improvements for lots of practical scenarios, and especially for coding, but also for RAG and structured outputs and all that good stuff. So yeah, gonna play around with it today and just learn about it and see what it's good at. Hopefully everything. All right, let me make this bigger. So here's the documentation from OpenAI about the GPT-5 models. So this is, sorry, this is a model family. So there's multiple models. Interestingly, they don't even list all of them here. So there's these three models here. GPT-5, that's like our full model, right? Then there's GPT-5 mini, and that's like pretty good, but it's going to be a bit faster and a bit cheaper. And then there's GPT-5 Nano for the simplest task that you want to go really fast. I've never actually used a Nano in any practical scenarios, but I have heard some people using Nano for things like keyword extraction, that sort of thing. So there might be some good use cases for it. Hello, hello, hey John, welcome. Now, the interesting thing is there's even more models than this. There's one that they're using in only in ChatGPT called GPT-5 Pro, and then there's another one that you can use on Azure OpenAI called GPT-5 Chat, and it is mentioned way at the bottom of this doc. It says there's two models, GPT-5 Chat and GPT-5 Thinking. Maybe that's the Pro. I don't know. And now it seems like there's 6 models maybe. But the ones that we can use in most places are GPT-5, GPT-5 Mini, GPT-5 Nano, GPT-5 Chat, right? So we can use them with Azure OpenAI. Presumably we can use them with OpenAI. Actually, funnily haven't tried it, but let's look at the playground for OpenAI and see what's in the playground. I know my Chat GPT doesn't yet have 5, even though they say they're going to default Chat GPT to GPT-5. But I don't have that access yet. I'm still waiting for it. I assume they're getting capacity for it on ChatGPT, so I still have all these old models. But OpenAI did say they're just going to straight up only use GPT-5 models, and that means that users don't have to think about it as much, which is good because trying to figure out what's the right model is hard when you're not just following model updates every single day, right? And constantly looking at benchmarks. So some of you might have access to ChatGPT. Hello, hey Judy. This is my first time trying LinkedIn streaming, by the way, so it'll be fun to see people's comments coming in from different places. All right, so we have, so if we look at, this is the OpenAI Playground, which admittedly I don't actually use very much, but here we go. So in the playground, we've got access to GPT-5, GPT-5 Nano, GPT-5 Mini. This one has GPT-5 Chat as well. So you can try all of those from OpenAI as well. So we got OpenAI.com, we got Azure OpenAI, and I deployed all of these yesterday. So I've got GPT-5, GPT-5 Chat, Mini, and Nano, all of them deployed in global standard. Oh, I see people do have access to GPT-5. All right, very good. You are ahead of it, ahead of me. As we were saying with my colleagues yesterday, that means you're in the lucky bucket, right? Because when we're rolling out things to users, users are like in buckets, right? So congratulations, you are in the lucky buckets. Hey, at least I got access to these. So I did have to fill out a form. So if you do want access to GPT-5 from Azure OpenAI, you do have to fill out this form. Let me link to this doc too. So I did fortunately get access to that so that I could try out GPT-5. I think we're still ramping up capacity for GPT-5 because I've had some timeouts and errors with that one, but all the rest have been working really well. So I have it there, but also anyone can try it out with GitHub models. So as long as you have a GitHub account, this is probably the easiest way of getting started with it. It's here. So GitHub models, just search for GitHub models. It looks like when I paste in the chat, I only paste to YouTube. So I'll have to learn how to be able to chat with LinkedIn. So here with GitHub models, we've got 5, we've got chat, we got mini, we got nano. And you can look at the parameters. Now, here's the interesting thing is that these top 3 models are all reasoning models, 5, mini, and nano. Chat is not a reasoning model. So that means that it doesn't attempt to do any of the thinking that the other ones do, but it is optimized for chat applications. So it could be a good fit if you're doing a chat application. But the other ones are all reasoning models, and you can actually change the reasoning effort, right? So here I'm in mini. So I'm going to generally use mini today because it works in my few experiments I've done so far. GPT-5 mini is great. It works really well. It doesn't seem to have the capacity issues that the full GPT-5 has right now, because I have been getting some errors with that one. So I think that's the one to test out. Now, what you'll notice is that you can do reasoning effort high, medium, low, or minimal. So minimal is a new one that they just added to the models, so that way, instead of, because before you have to say like, oh, I don't know, do I want high, do I want medium, do I want low, oh my gosh, I can't decide, right? But now minimal means like it's going to figure out, it's going to decide for itself, like, does this task require thinking or not, right? So now it's up to you, right? If you know that you always want low, go low, you can go low. But minimal sometimes will actually use no reasoning tokens at all. That's what I've seen so far. So, there's actually like, if you go low, it will always use some small amount of reasoning tokens. But if you go minimal, a lot of times it actually uses no tokens at all. I actually don't even know if I've seen it use any tokens yet when saying minimal. So clearly I need to get it to think a little bit harder. Yeah, so there we go. So that's it in the GitHub models playground. So I'm gonna code with it. So here I'm the repo that I'm using. You can just get from my GitHub page. It's just python-openai-demos. So this is the repo I have that has just lots of example code, and it's just easy to modify. And you can use it with OpenAI, GitHub, Azure OpenAI, any of those. I'm gonna make a little QR code if that's easier. There we go. Yeah, so we can, oh yeah, good questions. Okay, so is reasoning effort related with cost? Well, yes, because the tokens do cost you money, right? So if you cost more tokens, like, okay, so I do actually already have this running over here. So here, this is a RAG application. So this is the first place where I went and deployed GPT-5 Mini. So here you can see we actually have 2 stages where we use an LLM for this RAG flow. So first we take the user's question and we convert it into a good keyword search for our search engine. And here we have reasoning effort low. So that means we're saying, okay, always use a small amount of reasoning effort. Now, interestingly, this time it did 0 reasoning. Okay, I'm gonna try a harder query and see if we can get it to do more reasoning tokens than that. Let me try this one. So it's saying like, wow, so even with low, I thought with low it always did some amount of reasoning, but it looked like that time it said there were 0 tokens. So usually, what you want to do is look at your tokens that come out. Okay, good. So this time we said reasoning effort low, and we got reasoning 128. So it did take 128 tokens in order to think through it. Now, the OpenAI reasoning models do not expose the reasoning. That's different from DeepSeek. The DeepSeek model does expose its reasoning, so you can actually display it in the UI. But at least when you're using them via the API, the reasoning process is not exposed. So all we know is that there were 128 tokens where it thought through this and came up with it, right? So that means that 128 contributed to the total token cost, and we pay per token cost. Yeah, it does contribute to the cost. It also contributes to the latency, right? Like those 128 tokens happened before the answer came streaming in, right? So if it's thinking for 120 tokens, that's 128 tokens where the user is sitting there waiting for an answer to come back. And especially for this one, we have 2 calls, right? We have that first call, and then we search the Azure AI search using this query, and then get back the results, and then I send it to GPT-5 Mini. In this case, I decided to use reasoning effort minimal, and so there you see in this case it just decided to use 0. So when I've been doing minimal, it's been actually using 0 every time. So let me change this to, I should be able to change, let's see, reasoning effort. Let's go high, so we can see. All right. So this time I'm going to force it to like really reason more. And let's see. And yeah, that's the other good thing to look at is the pricing. Admittedly, I don't look at the pricing a lot because I try to use whatever is the free version or use, my Microsoft corporate account for demos. But definitely, we should look at pricing. Simon Willison, of course, we always got to look at this Simon Willison's blog whenever we're talking about new models. And here he's got a great post about GPT-5 pricing and model card. So he's been actually playing around with GPT-5 for a while. And so he's got a little comparison here, right? So GPT-5 mini. So GPT-5 mini input per million tokens and then output per million. So in terms of reasoning tokens, you want to look at the output, right? So this one is $2 per million tokens. Compare that to 04 mini, which is $4.5. GPT-4.1 mini was 1.60. So it is actually more, so that's significant. It is actually 40 cents more expensive, than GPT-4.1 mini for a million tokens, which feels like it's not too big of a deal, especially if significantly better. But the input tokens are cheaper, interestingly. So that's very interesting. So yeah, you'd want to consider that, right? Because given it's a reasoning model, the reasoning tokens will contribute to that cost. Let me link this one as well. You should always subscribe to Simon's blog to find out what's happening. All right, this one is still. Oh well, the other issue is that when you do when you ask for it to reason a lot, it can take a lot longer. So I guess they're really still going here. Let's see. Completion token, reasoning effort high. Okay. Yeah, I'm just looking at the full request that went over it. So that one's still generating. So let's also just try it from code. Okay. So here I have really basic code. I'm using the OpenAI Python package. And here I'm using GitHub models by default, but I could also point this at the models on OpenAI.com or Azure. So the first thing I found out actually, because this was code that I originally wrote with GPT-4o. So I'll show you what happens if I run this code. I get an immediate error that says temperature does not support 0.7. Only the default value of 1 is supported. So this is something I actually didn't know, is that the reasoning models don't support temperature. And I couldn't find a lot of discussion about why that is. The thought is that, maybe because the temperature might change throughout the reasoning process, maybe they need to be able to control that. So if you're used to being able to control temperature, you just can't anymore. So bye temperature. But we should be able to say reasoning effort, right? So this time we can do reasoning effort low. And then what I can do is also look at the usage. So it's response dot. Let me remember where the usage is stored. Here, we'll just use the debugger and then I'll be able to see. All right, let's see. So we'll do this in debug mode so we can see everything that's in the response, right? Let's see. All right, let's see. Okay. All right, so we're gonna go make that network call. Going through. All right, we're doing GPT-5 mini. Okay. All right, we're getting back that response. Go, go, go. Oh, it's okay. I reached the rate limit, so I might switch over to Azure OpenAI because probably the new models have lower rate limits on GitHub models because I'm using this for free, right? I'll just go forward on it. Okay. All right. So Given the rate limits, and it's boring to look at rate limit things, I will go ahead and set up my Azure connection instead. So it's going to be, let me get the values from my other one. Okay, it's going to be, oh, I can just look in here too. Okay. So here we go. And then my deployment name is this, and the API version looks good. All right, so let's rerun this. And this time, hopefully it should rerun, use my Azure quota. To try running that. See some cool comments. Okay, so Justin says, swap to GPT-5 Mini and see much better responses to following the system prompt. That's great. Yeah, I'm curious what are you doing RAG or are you doing agentic? Those are kind of the two big things. Oh, okay, here we go. Still testing it with the RAG responses, but seems good. Yeah, so I've actually been running full evaluations on the RAG, and I'm pretty impressed. So I'll show that. Oh, I need to do a login. Sorry, let me do a login. Since I'm inside a code space right now. So let me go and make sure I log into the right tenant. Yeah. Oh, there it is, tenant ID. All right. All right. Do the boring stuff of logging in, yada, yada. And then I'm going to do a big old two-factor dance. Okay. Enter code. Do this. Going here. Getting ready for my authenticator. Oh, good. All right, all done. All right, let me try it now. So I think generally, like in terms of use cases, there's a lot of discussion about use cases. I think the use cases for GPT-5 is everything. Yeah, I guess because basically it's a reasoning model, it's a multimodal model, it's a chat tune model, it does structured outputs, it does tool calling. So because that's why ChatGPT said that, or OpenAI said that they're deprecating all the other models, because they basically are trying to, I think they are particularly trying to make something that's really good at agentic coding, because lately people have been all using like the Claude models for that. So I do think they put an emphasis on that, but I think we're also just thinking of GPT-5 as like the model to use, for every scenario, right? The only thing you can't use it for is image generation, as far as I understand, and for the real-time audio, right? If you're doing like a voice application with real-time audio, then you would still be using the real-time models. Okay, and what? Okay, all right, I'm gonna run this code locally. Let me just go over here, just because it's boring to watch. Token errors. All right. Okay. And this one, we're going to say Azure, and it's going to be .env. I'll just go and take this, make this my endpoint, and we'll say GPT-5 mini here. Okay. All right. Let's go. And the version is this one. All right. Okay, now it is running. We did reasoning effort low. And here I'm actually inside the code base where I've already used it. So I can also look here Okay, so we got a response. This is not something that requires a lot of reasoning, but what we can do, so you see you can do reasoning effort low, you can do minimal here, and then the thing to do is to look at your usage, right? So let me see where we do stream. Okay, include usage. So we want, so where do we get the usage tokens? Total tokens. Usage. All right, so it should be, so here, try to remember where we get the usage from. So let's go ahead and just look at the whole response. Okay, question is, what am I doing? What am I doing? I am using Python with the new GPT-5 mini model. Okay, so here we can see the full response, and so here's usage is the one that we're very interested in. So we can look at response dot usage in particular. So you notice it's actually faster now that I'm doing reasoning effort minimal, because a lot of times minimal is going to use zero tokens, right? So if we look at this one, we can see completion tokens, prompt tokens, total tokens, and in the details, it says reasoning tokens equals 0. So the question is, when does it decide? So we need to like force it. Like, you are a helpful system that thinks really hard, right? So we need to get it to like think a little harder, right? Do something more complicated than writing haiku. So, write a Python program that converts images to base 64 encoding, like, I don't know, ping image files, right? Let's just see if it's going to think a little bit harder. Okay. Ignore that. Okay, so now it's taking a bit longer, and I assume that we're going to see that it requires more tokens. Okay, so here, if we look at the tokens this time, it still used reasoning token 0. So this is what I'm trying to figure out about minimal, is that I still haven't gotten it. So how do we get it to think hard? Ultra think. I know ultra think is like a special code word for the Claude model. Yeah, this one. The other thing is that we could stream it, because right now it's it's taking time to come because because of we're doing the whole response at a time. So if we want, we can do streaming. So it's, these models, they support everything like streaming. The first reasoning models didn't support streaming, but now we've got that. Stream. Okay. All right. So now we can do streaming response. Okay. So we can do streaming, so we can get a little faster. Tell it to use reasoning tokens. Okay, use reasoning tokens. Yeah, everyone thinks we should tell it to use reasoning tokens. Okay. I mean, I'm telling it here. I'm not sure how else to tell it besides in the prompt, because we've said reasoning effort minimal. Now that we're streaming, we are going to have to tell it to explicitly include the token count, because that's not default. So we got to go here and say, what is it? Stream options equals include usage true. Okay, so now hopefully we'll get that. And let's see, where do we get the dot usage when we're doing streaming? Dot usage. Include action and calculation dot response dot usage. I'm just trying to figure out whether extra chunk dot usage. Okay. All right. So here, the final chunk at the end of the streaming should include the usage. Okay. All right. Things get a little fancier when you're. Okay. So we'll go like this: if event dot chunk dot usage, and we'll just get rid of all this stuff, and we're just gonna print it out. print usage. Okay. And event dot chunk dot event chunk dot usage event. Okay. All right. So let's try out the streaming approach. Okay. All right. Oh, we got some think hard. I know some people did actually. I've been putting think hard when using GPT-5 with GitHub Copilot, but obviously we don't want to have to say think hard. Like that should be built into a different layer. But okay, John does have a suggestion for. Oh gosh, I can't even answer this one. If it randomly, what's the probability? So it's a probability question. Okay, show base steps. All right, great. Oh, and you asked GPT-5 to come up with a question. Okay. So here, okay, we got reasoning token 0 again. All right. All right. I'm going to try John's, although wait, does it let me copy? Let me like inspect element and copy yours. No. StreamYard doesn't let me copy, so I'm going to have to just kind of type that. Okay. So a factory machines A, B, C produces 50%, 30%, 20% of items respectively. Their defect rates are 2%, 5%, 8%. If a randomly picked item is defective, what's the probability it came from machine C? Show base steps. Okay. And we still have think hard. All right, let's try that one. And at this point, if it doesn't include reasoning tokens, I'm going to start thinking minimal. That maybe there's like a that actually came in really fast. Reasoning token 0. Okay. At this point, I feel like either there's a bug where it doesn't tell us the reasoning tokens, or minimal just never uses reasoning tokens. I don't know. Has anybody actually seen reasoning tokens be used when using minimal? Yeah, well, so we have some, like, it doesn't think the task is hard enough to use reasoning. When does it start? When does it consider using the reasoning token? These are all great questions, because so far I have not seen it ever use the reasoning tokens, right? Whereas if we do low, we immediately see like this will, we can do it again. It'll probably be a little bit slower at first to come back, right? The last response was actually quite fast. This time it's going to be slower to come back because it's clearly doing its low amount of reasoning. And here we can see reasoning tokens 128. Generally low is often around like 84, 128, something around that. So yeah, so I'm thinking that either minimal just almost never decides to reason, which makes me wonder, like maybe most of the time we don't need to be, using reasoning models. Maybe that doesn't really add anything to it. Maybe that's what they found, is that maybe people were over using reasoning models, and so they just, rarely use it. Or there's a bug that means it's not showing the number of tokens. But given how fast these things are coming back, when the reasoning effort is minimal, makes me think that it really isn't doing reasoning. So yeah. So interestingly, that doesn't seem to be working. Yeah, there's some questions there about exactly what minimal means. Now, keep in mind, this is with GPT-5 mini. Let me go ahead and change this to GPT-5. Now, let me warn you that I have been having issues with my GPT-5 full deployment. I'm getting errors like every other time. So I reported that to the team to try and figure out what's going on. But it does work the other half of the time. So we can go ahead and try it out and see, like, okay, if we use GPT-5, well, here we're on low. We should change this to minimal because it's going to be slow. All right, so let's try GPT-5 with minimal, because maybe it's the fact that I was using mini and not GPT-5. So let's check this out. Oh, I see Justin has a suggestion. All right, I wish I could actually follow your links. I wish StreamYard let me copy and paste. Okay, I will, let me open that. Okay, this one once again used reasoning token 0. Cookbook, open, oops, not typing that correctly at all. Okay, OpenAI cookbook, GPT-5, new params and tools. All right, let's check this out. And let me also put this in the chat for the folks on YouTube. Okay, so new params and tools. So, oh, verbosity. We didn't play with the verbosity parameter, so we should play with that. Free for function calling. Interestingly, okay. Context-free grammar. That's a really interesting one. And then minimal reasoning. Ideal for deterministic lightweight tasks where explanations aren't needed. If not specified, effort defaults to medium. Okay, well, let's try some of the other ones. So even with this was with GPT-5, and so even with GPT-5, it did use 0 reasoning tokens for that task. Yeah, if we change this like to reason effort high, oh gosh, let's see how many tokens it uses for that. Also, I haven't even been paying attention. What is the right answer for this question, right? So this one says 39% probability. I haven't been looking back to see 39%, 39%. All of these have been 39%. So, you know, it's apparently wasn't that hard of a problem for this grand problem, model that is better at math than I am. Yeah, it's too easy. John, you got to get a harder problem here. All right, so here, when we do reasoning effort high, we can see reasoning tokens is 704. And I got the same answer, which seems to, so I, it didn't need to do all that reasoning, right? So it even got that answer with 0 tokens, right? So it actually realized correctly that it didn't need that many tokens. The question is, when does it need tokens? I don't know. So what we've seen is that minimal seems to very often use 0 tokens, and maybe that's good because maybe we've been overusing reasoning when we don't really need to. So let's try something else, right? So we also have verbosity. So verbosity, and the values for verbosity are low, medium, and high. All right. So this was kind of interesting because we said, all right, I'm going to remove the show base steps and then say verbosity low. And this time we'll just go back to reason effort minimal because it's going to be the fastest, right? Remember, it's even faster than low. And then we'll go and check it out. Oh, you know what the issue is? They really want us to switch over to the responses API, which I haven't really used very much at all. So apparently, or maybe I just have to update my SDK. Let me check if there's a new OpenAI package here. OpenAI about an hour ago. Well, that's promising. 1.99.5. That's probably not what I have right now. Let's see. Very unlikely that I have it. Okay. Oh, I have an ages old one. Oh my God. So we're going to do 1.99.5. Looks like we're getting really close to 2.0. All right. Going to install this one just to make sure that, because maybe I can get that verbosity parameter from the latest version of the package. We should be able to look at the changelog and see if they added new parameters, or we'll just know if it works, we're great. I can also, let me go. Okay, yeah, that worked. So you do need to update your version of the OpenAI Python package if you're using that in order to be able to use the new stuff. So what we see is 39%, and it was pretty terse. So we can do verbosity high. So we can see this one was a total tokens of 239, right? So completion tokens 168. That's what we got for that one. What is the default verbosity actually? Verbosity default is medium. Okay, interesting. All right. So this time we did medium and we used 214 completion tokens. Okay, and that was for verbosity high. Which wasn't really that much more verbose, but this is not, this is not our like standard kind of RAG scenario, right? That might be where you'd want to use verbosity to control, how chatty your chatbot is. So yeah, so there we go. So low, medium, high, and then there's also, okay, so then we tried that out. Oh, so the length and complexity of generated code. Interesting. That could be good because some people say like, oh, these coding agents, they like write too much code unnecessarily, right? So we can go back to this one. Let's see. All right, we're gonna get rid of think really hard. Actually, I don't even think we need a system prompt, right? I don't think our system prompt is really adding anything. You don't need to tell an LM to be a helpful assistant. It's literally what it is. It's trained to be a helpful assistant, so we don't need to put that in the prompt. So we're like, write a Python program that converts in ping file to base64. Okay, base64, and then we'll say verbosity low, and see if that changes the program that we get out. I see a claim that nobody uses VS Code in that theme. I use VS Code in that theme. I guess I'm a nobody. Okay. All right. So we said verbosity low, and this doesn't look like particularly low verbosity. It's actually a fairly long response. So it said, here's a program. Save it as this. It included a doc string. It included argument parsing. I would actually say that's a fairly long response because I could imagine giving just this, right? This is what I would consider to be like very terse response is just, okay, here's the file, here's the function, takes a file, it outputs, base64. So let's try that again, now with verbosity high. How much more verbose could it get? Let's see. It's slightly more verbose. So this time completion token 622 versus completion tokens before of 585. Okay, barely a difference. So I'm not seeing a difference here. I do think this is worth exploring though, because so as I was saying, I have been running the evaluations for this one. Oh, I don't know what that status was, but let me show the evaluations that I've been running for it. Let me also just retry that one. So let me see here. Okay. So I can show you the results of the evaluations. Here we go. So whenever I change models in this RAG repo, I always run bulk evaluations. I've got a set of 50 questions and answers that I run against the new model, and I can compare and see oh, okay, how does this answer compare to our ground truth answer? Does it look, good or bad or whatever? So I ran all those evaluations and yeah, so it's really interesting. So here are the results. Let's see if I can make that bigger so you can see. So the baseline, that's what we currently default to. That's GPT-4.1 mini. And so what you can see is I measure groundedness, relevance. So these two are they use an LM as a judge. So the LM will say, oh, this answer is grounded in the search results. So we generally want high groundedness, meaning that it's sticking to the information and it's not making up anything. Relevance is whether the answer is relevant to the question. So we want high relevance. Then we have the answer length, which is how long the answer is. Then we have the latency, how long it took, and that's important since this is a user-facing application. You can see the baseline is actually quite good, about 3 seconds. And citations matched is compared to the ground truth, the citations in there, like which PDFs and page numbers, did the new answer match that citation? So we want high citation. So those are our metrics. And so it's interesting to look at O3 mini because that's a reasoning model. And we can see it does get really high groundedness, one of the highest values here. But then the latency was 20 seconds, right? So it was okay, well, that's not a reasonable amount of latency. Now, yesterday I ran the GPT-5 model. So you can see GPT-5 chat and GPT-5 mini with minimal reasoning. And they get very high groundedness too. So they're getting 4.8 values, and that's higher than our baseline, right? That's even higher than O3 mini got. So really high groundedness, which is great. Their relevance, the average is actually, for some reason, that relevance isn't as high, but I think I know why that is, and I'm okay with it. So it's interesting that the relevance did go down on these ones. But I think that's just because of how we're measuring it. I'll show you the answers to give you a feel. But what's really interesting is look at the answer length. So the answer length for GPT-5 Mini is 900 characters long on average, and that's a lot. That's a lot longer than anything else, right? GPT-4.1 Mini is pretty verbose. That was 830, but 940 is our highest value here. GPT-5 chat was only 600 characters, right? So I would definitely experiment with doing, maybe verbosity low here to see how that affects it. But sometimes you want a long answer. Like if a long answer is a better answer for the question, then it's it's good to have. So that's why you really want to like look and see. Latency, we see 3 seconds for the chat model and 7 seconds for the mini model. So so far when I'm looking at this, I'm thinking like, oh, maybe the chat model is the right fit for it, right? Good numbers, good latency, good length. But then the thing to do is to actually look at the answers to see the ways in which they're different. So if we compare it, we can compare it to the baseline. So look at GPT-5 Mini, compare it. So we compare that to GPT-4.1 Mini and see how they compare, right? So this will show like side by side. And so I go through them to kind of get a feel for, what they're different, like the formatting is different, maybe this one's using more markdown. Now what I found the most interesting with GPT-5 Mini is that it very often says, I don't know. And I think that's great because a lot of these questions actually weren't are hard to answer questions. And my concern with the old models is that a lot of times they would pretend to know the answer, but they didn't really have enough information to fully answer the questions. And this model, these GPT-5 models, all of them have been really good at saying like, oh no, actually, like I don't know the answer to that. This is what I do know. It's like often will says, oh, this is what I do know, but I don't know the full answer to that. So, and I think that's probably why we got lower relevance, because when it says I don't know, it considers that not to be as relevant. But I would rather have it say it doesn't know if it doesn't feel fully confident, right? So I saw that a bunch actually. So here's another one where it says, I don't know, here's what the sources do have. And it very often will just start off with this straight up, I don't know, right? So I feel like when they trained it, because they did specific training to reduce hallucinations. And I feel like when they did that training, they maybe specifically trained it to just start straight off with saying, I don't know, right? Like, is it all there? Another, I don't know, right? I don't know. So really good at saying, I don't know. There we go. And then this one also asked a follow-up question. The question is incomplete. Do you mean the Northwind Standard Plan or Northwood Health Plus? Whereas we compared to here, it said like, oh, Northwood Health covers the following services, blah, blah, blah. So instead of asking the user for a clarification, it just, just tried to answer it all the possible ways, whereas this one asked for clarification. So I think they decided it was better to have the model ask for clarifications than to like steam right ahead and come up with an answer. So definitely a big difference in the huge prevalence of saying I don't know, which I think is really good for RAG. I think we'd much rather have the model say that it doesn't know and say what it does know than to just steam right ahead and pretend it knows. So there's probably like a good number of these do start with I don't know. And that's why the relevance scores are lower. So that's really interesting. I do recommend doing evals like that. Yeah, I'm excited about the I don't know. Now the tricky thing is that I have to because this is synthetic data that I'm doing this on. I'd have to really dig into the data. Like these are made up documents, they're sample documents that because this is for a public repo. So I'd have to really dig into the data to see if I don't know is actually the best answer. But I know it is the case for the sample question. This is what I posted yesterday and put for the thumbnail of this, right? So we have this sample question, what does a product manager do? And we've had this sample question in this app for the last 3 years. And we only recently realized that this is actually hallucination, because in the source documents for this RAG, there is no role that is product manager. There is a lead of product management and like a senior manager of product management, but there is no actual product manager role, right? So it shouldn't actually be able to answer the question of what a product manager does, because it doesn't know that for this company, right? It may know that generally. And this is exactly the kind of question that trips up an LLM. Like if it knows what a product manager does from its weights, right? Because it's seen that so many times in its training data. It desperately wants to say that it knows what a product manager does, but there is no role description for product manager in the docs. So I was really impressed when I ran GPT-5 Mini with this question and saw that immediate I don't know. And it told why. It said none of the sources give a general definition of product manager separate from manager level roles. And so when I saw this, I was just like, oh my God, yes, it finally caught that hallucination, right? So I know at least for this question, the I don't know is very much deserved. And I was really excited when I saw that. So definitely check it out for RAG. I'm really excited because the only thing I want in life is for a model to admit it doesn't know, right? Like as soon as we get to that point where models know what they know and know what they don't know and can admit that, like then we can start having way more confidence in our systems. So I think it's definitely compelling for RAG. Let's see, let's go back to, now the other thing they said that they really worked on was structured outputs, right? So we can take a look at a structured output example. So we got let's see. So this one, we can both have it look at an image. Oh, here, this is a fun one because it'll do everything. Okay, it'll do both multimodal and structured outputs. So let me do new file here. Okay, and I'm just gonna paste in this. Okay, all right. Let's see if that's set up. Okay. So, with structured outputs in Python, we're using Pydantic base model to define the outputs that we want. And then I have a function that converts a file into base64. That same function we were trying to get to generate. And let me get this image and bring it in. So what we can do, this is a multimodal model that also supports structured output. So we should be able to do this and it should work great. So let me get the actual image here. Let me download that. All right. So this is an actual image that I took from a local website that sells nursery that sells plants. Okay. All right. So now we've got that, and let me try. We'll just call it image chat py. All right. Now go over here and run it. Okay, so I just need to change my variable name here. Ooh, interesting. Okay, we got a little error. Response format only enabled for API versions. So I forgot. We do need to use a particular API version when you're doing structured outputs. So that is this one, 2024-801 preview. Okay. All right. So let me use the right API version there. That's only when you're doing Azure OpenAI, where we have API versions. OpenAI doesn't do versions, so it can be a little confusing with the API versions, but it should be updated now. So we're passing this image to the model and saying, hey, extract the information from the table. And we tell it the response format is this plant inventory response format. So it should read the image and give us back the data in this structured format here. And let's see, which one are we using? We're using GPT-5 mini. Okay. And I guess it's just taking a little bit of time. There we go. Okay. Because we did have it parse this whole table. So what you can see is I basically had it convert the table in the image to this nested object here, right? So plant inventory has a list of annuals, a list of bulbs, a list of grasses. Those are sections of the table. And then each of those has a plant that has these attributes here. So you can go through this and you can see. And, you know, what you'd want to do is run an evaluation to confirm that, okay, yeah, this definitely, you know, this matches the thing, right? And confirm that you're getting high accuracy from something like this. So it looks good. I don't see any obvious hallucination here, and it's all adhering. I mean, this worked with previous models too. What we could try, I have one that's harder. The hardest one for previous models was giving it, I don't even know if this will work, giving it 20 pages from a PDF and having it convert all of them. Let me try that one. Because when I did this with the other models, they would end up hallucinating. So I'm curious if we can get a better response from this one. So I'm gonna move it in here. Okay. And I also need to grab the PDF that we're parsing, plants.pdf. Okay. Do and .pdf. Okay. All right. So here we go. We're going to be using Azure. And this is our connection to Azure. And here. All right. And then one. All right, let me run this in here. Okay. Install the Jupyter package. Don't have it in this environment. Let's see, is it gonna work? Oh, I need it. Let me just stay in. All right. So using Azure OpenAI with okay. All right. So now what we're going to do is install Pillow and PyMu PDF. So Pillow is the Python imaging library, and PyMu PDF is a great package for extracting things from PDFs. They also have an additional package, PyMu PDF for LLM. So if you have a PDF and you want it to ingest it for an LLM, it'll take the PDF and convert it to Markdown, which is really cool. So definitely check that out if you haven't seen it. So here we're opening the PDF file, and what we're doing is just saving each of the pages as an image. We could also, of course, convert them to Markdown, but here I'm testing out the image functionality. So we're saving them as images, and you can see them all saved locally now. So I have page 0 to page 14. And then we are sending them to the vision model and asking it which plants are listed. Okay, so what is the error we got? Oh, temperature. Yeah. So we cannot do temperature. All right, so we're going to get rid of temperature. Let's do reasoning effort minimal, which will probably be 0, because as we know, reasoning effort minimal seems to always be 0. So let's see, we've got model, messages. So here I'm not using structured output. I'm just straight up asking it what plants are listed on these pages. So I haven't even told it what format I want. I'm just giving it a lot of images. So this is, when I've done this in the past, it's been good for the first page. And then by the time it gets to page, you know, like 3 or whatever, it starts completely hallucinating, and then like it becomes like just kind of nonsense. So it'll be interesting to see whether it can cover it. Now, I don't know how many people are actually have this use case of sending, 14 images. But it's also true, like everybody always asks about context, right? Like if you're using GPT-5 for coding, right? So here I've got GitHub Copilot open, and I've got GPT-5 that I'm using here for GitHub Copilot. So it's important how much context a model can reasonably look at, because a lot of us are working in very large code bases. We might have even a single file that's 10,000 lines long, because you know how things get when you're in a legacy code base. You'll have this one file that's 10,000 lines long, and you can't manage to split it up no matter what you do, right? So it's helpful when our LLMs have long context. Okay, so it did come back. So um, let's see. So it looks like it actually it doesn't look like nonsense, which is really good. And it said each page. Wow, looks pretty good actually. So what I should do is actually look at page 14 and 15. And here it actually asks, what format would you prefer? So it's being fairly conversational, even with the mini. So let's see, page 14. That's more oaks. That's right. Now, Quercus. So it just said 14 to 15. It's only putting a few things. So page 15, Agrifola, Verbidifola, Douglasy, Gariana, Lobata, Umbusar. Okay. And all right, I think I have an off by one here. Yeah, I labeled mine. So this is the actual page 14 and page 14 and page 13. So I think I had a hard time like dividing things correctly. But we need to like run an evaluation to see how it does. I think that this looks pretty good. This looks a lot better than before. So it's pretty impressive, right? It just took in 15 PNGs and extracted the Latin names for them. And these are like crazy Latin names, right? Like I can't even spell most of these names, and I own these plants, like they're in my yard, but I can't spell them half the time, right? So its ability to understand images is quite good. Okay. All right. So what we're seeing, it's a good RAG model. It's a good multimodal model. It's a good structured outputs model. It should also be a good model for tool calling, because they talked about that quite a bit. And I actually am using it, like this RAG one uses it. What is the error that is happening? Timeout. Oh, the operation was timeout. That's my favorite. Okay, let me restart the server. So this RAG repo does actually use tool calling as part of. Let me show the tool that it uses. Right. So it's a really basic tool. It just says, oh, take the user's query and call this function. So it's just a way of getting back a good search query. So it's not a very complex use of tool calling, right? Because what you really want to see is like, okay, when this model has multiple tools, how does it do with multiple tools? And so GitHub Copilot's actually a good test of this, right? So this is something I did yesterday where I said like, okay, add an entire about page to this app, and it did it, right? It first came up with this list. This is a new feature in GitHub Copilot where it makes a to-do list, which is pretty fun, pretty cute. And then you can actually see as it goes through the to-do list. So it does lots of reading, it does the things. It can also use servers, right? So I do have a bunch of built-in tools here, and it was able to use these tools as well. And so it does look like it's a good agentic model as well. And I think the best way to test that is if you already have some agents you've written yourself, like try it out. But also if you're in VS Code, use GitHub Copilot, change the agent mode to GPT-5, and use some MCP servers and see what happens. Let me see if this is running now. Okay, so yeah, good question. Would you check every output to ensure it's accurate, or kind of skim? So if this was like if that use case, the chat one was one that I was going to be doing a lot, then I would set up evals for it, right? Where was the IPNB? That one. Yeah, I would set up an eval, right, based off of like some examples, like so here, if it was tables or if it was receipts, like whatever I was doing, right? So you want to set up evals. Let me show you another one where I've got evals for this sort of structured outputs. Let's see. So I have my personal LinkedIn agent, which is always a fun demo. Personal LinkedIn agent. Okay. So this one I've got evals for. So this is my agent. Let me run it right now, actually, because I haven't run it. I haven't run it this week, and I should. So let's try it out and see if it's working today. Dun, dun, dun. So what this should do is it's going to use browser. It's going to use Playwright to open up a browser, and it's going to click around the browser. This one's using GPT-4. We can try switching this to GPT-5. So there's Dawn, and here's the browser. So it goes to my invitations, and it looks at each of the invitations and decides whether to accept them. So notice my hands are not on the keyboard right now. Here's my hands. They're not doing anything. Everything is being automated via Playwright, and it's going through and it basically looks at each person. If it's not sure, it opens up the page and decides whether to accept them or not. Most of the times it decides to accept them, right? So, this is an agent whose job is to make a decision. And so if I'm going to evaluate this one, I'm going to be looking at, do I agree with its decisions? So I set up evals using the pedantic evals, and I made up a bunch of cases based off of real ones that were fairly, diverse in terms of ones I would accept, ones I wouldn't expect, right? So I said, okay, here's the name. This is what you're going to be sent as the agent. In this case, you should accept, right? Action, accept, action, accept. Action undecided. That's another valid action, right? So that's the general approach I would take to evaluating something like more like structured outputs or agentic stuff, is making sure that you agree with the output from the agent. So let's go ahead and try this one with GPT-5. Let's see, GPT-5 mini, our new favorite, GPT-5 mini. And let's check out what is the endpoint that we're using here. This one. All right. OpenAI.azure.com. Okay. And okay. All right. Let's see. If I overrode enough things there for that to work? Oh, okay. Am I participating in the Microsoft Global Hackathon this year? I never really have participated because there's always some other event happening. And once again, there's a different event happening that week. So I will be going to the Redmond office, but I don't think I'll have time for the hackathon. But it will be my first time going to the Redmond office, or even my first time going to a Microsoft office ever while being an employee at Microsoft. Yeah. Oh, let me open up the browser so you can see. It opened up in my other tab. So yeah, I don't think I'm doing the global hackathon, but we'll see. So now we're doing GPT-5 mini, and it's doing a good job here. So what I could do is rerun the evals with GPT-5 mini and see how it's doing with the evals. So once it goes through these ones, I'll run the evals, and so we can see if it agreed with my test cases. So interesting is, like, when you run evals, you have to make sure your test cases are good, because if you like test cases are bad, then your evals will give you the wrong messages. So it's like really, really important that you put a lot of effort into your test cases and your ground truth that you're using for evals, so that you're getting good signal. Okay. All right. So that now let's try running the evals. So this one. All right, so let me just try running it. I don't remember if there's something special I have to do, but we'll find out soon. All right, so it's just going through. And this one's not even using the LLM as a judge, because I thought in this case, like really, I just care about the action, so I don't even need an LLM to judge. So it says averages 67%. So that means there were some that I said, that I said, the correct decision is something else. So I could go through this and see like, okay, what were the ones where it didn't agree, right? Like this one, right? So Ethan Smith, this was one where I said undecided, and this one said accept, right? And if we're like, so my criteria is like, are they technical, and like, are they going to have technical posts, like, because that's what I like to see. And this one, it kind of has a hard time with, and sometimes it says accept, sometimes it says undecided, right? So once again, like, this isn't a great eval, because even I don't even really know what the right answer there is. Some things are fuzzy in life. But yeah, generally it did a good job. So it looks pretty good. So that's what you want to do, be running these evals. So yeah, okay, so we've done something kind of agentic. We've done some tool calling. Oh, let me see if this one is running now, so we can take a look at that. Let me check the output over here. Okay, that looks like completing. Okay, great. Okay, so interestingly, this time it did the hallucination, right? It says it answered the question. So these things are variable. Like sometimes you'll get different responses from other times, and it's interesting to see when that happens. But here, the first step is actually a tool calling step, right? We say GPT-5 mini, reason effort low, and this time we use 64 reasoning tokens for low. And this is one where we give it the the user's question, what does a product manager do? And we tell it to generate a search query for that, right? And what I'm noticing is that it is generating way different of a search query than the previous models, right? Like, look how long this search query is. It's like, it's really, really long. In the past, when I've done like GPT-4o, it's been like product manager responsibilities, right? That's it. But this one is like really expanding that. It's like day-to-day tasks, product lifestyle, so required strategic plan and roadmap, presence, stakeholder management. I think it's almost too long. So I'm not really sure if I like what it's doing. This GPT-5 mini, what it's doing here. Like maybe the reasoning models aren't a good use here. Like maybe we should actually use like GPT-5 Nano for this step of generating the search query. Or even GPT-5 chat or something like that. But that's something like, once again, you have to run evaluations and see like the fact that it's generating these really long search queries. Is that a good thing because it's getting more relevant information, or is it actually getting more noisy information because it's kind of adding a bunch of things that weren't in the original question? So that I do wonder about this, whether this is actually an improvement over the previous tool calling result. So it's also worth evaluating things at each step. Okay. All right. So yeah, and then the other final use case is using GPT-5 in order to do some coding in GitHub Copilot, right? So let me start a new session here. So if you have the latest VS Code, you can use GPT-5. So we can say, let's see, do I have any changes locally right now? Oh, all the stuff we just added. That's fine. All right. So I'm going to say, add a new about page to the application that describes the chat task tabs. Okay. That's it. All right. So it's gonna start thinking, and hopefully it'll make a to-do list, because I really like when it makes to-do lists. The reason it's making a to-do list is because I have this optional setting, this one, to-do list enabled true. So if you do like to-do lists, oh, it did make it. Yay, look at that. Oh, it's going to build a test. I like it. So it's going to inspect the front-end structure, add the about page route, add a nav link to about, write content for about, and build a smoke test. Okay. Yeah, so I really like this to-do list structure because you can just look at it and get a high level idea of what it's doing. And you can use this with any of the models. This is independent of GPT-5, but it's something that I started using at the same time as GPT-5. So it's doing, this first step here of checking out all the code. Now, one thing that would help is if I if I had a Copilot instructions file, I actually have another branch where I've added that. So under your GitHub folder, you can add a Copilot instructions file. And that way, every time you're using Copilot in a repo, it'll just see it. I can show you like what it's going to look like for this repo once I merge that, branch. Okay, multimodal, this one. Okay, I could even paste it in already, but here we go. So Copilot instructions, right? So this is what I'm going to have in this repo eventually. So it describes the overall code layout. It describes how to add new environment variables, because that's a little tricky. How to add a new setting, because that's a really common thing people do. How to add a new test, because that's a really common thing to do too, right? So this actually really helps GitHub Copilot to have this just laid out here, because it saves it a lot of research time to figure out, right? So just having it right here is really helpful. So I do recommend, if you're using GitHub Copilot a lot with a repo, is just add this GitHub/Copilot instructions.md. Let's see. So Jack says, can you confirm if system role prompt is not affecting the results and we should use the developer role? That's a great question. I've actually never used the developer role. I know that it was like a new role that they added. Let me look. There was another bookmark. Okay, GPT-5 prompting guide. So GPT-5 prompting guide. So let's see if it says developer. Well, developer is hard to search for. Okay. All right, they don't. Maybe this isn't system prompt. This is about system prompt. They're not specifically they don't seem to be really talking about whether you call it system or that. So let's go back to the other one, which was here, developer message. Okay, they are calling this a developer message. So that's interesting. That makes me think that we should be using it. Let's see, input. Okay, well, that's what the response is. That's the responses. Constraining outputs, preambles. What are preambles? Oh, okay, that's about chain of thought. Okay. It does recommend using the responses API, because then it'll pass the chain of thought across a conversation. So if you have the choice to migrate to the responses API, you might consider doing that to get better token caching and chain of thought passing, I think is the advantages. Okay, so that's not really talking a lot about this, but let's look at just text engineering, right? Input, message, prompt engineering, message roles. Okay. Developer. Yeah, so it doesn't even talk about system prompt anymore. Gosh, so am I behind the times? I tend to use system prompt because it's the most compatible across. Like if I'm using Olama or something, it knows about system prompt. But it does seem like they're really emphasizing developer now. And I don't know, maybe if they consider it just to be the same thing. System versus developer role for OpenAI. Why the change? Okay, I feel like it's actually kind of an alias, where they're trying to make it clear. They do have this really nice like explanation of the chain of command, and this change came along with it. But yeah, I'm a little confused as to whether system is basically an alias for developer now, like if it's just a naming change, or if it is actually being treated differently. It's a great question. Okay, Jack says, how can we automate the testing of new models for our use cases whenever these new models come out, as prompt changes can potentially introduce regressions? Yeah, that's a great question. So that's what so that's what I was doing with the evals, right? So right. So whenever I add a new model, I'm going to rerun my bulk evaluation, and that's going to run on all my ground truth questions, and then I add it so here in my evals folder, I've got my, current baseline, the defaults, and then I've got other things I've compared to in the past, and then the new potential one like GPT-5 Chat, GPT-5 Mini. So I'm always tracking those changes. It is hard because you need to keep everything constant, right? You need to keep whatever LLM you're using as a judge has to be constant, right? So right now I'm using GPT-4o, but if I decided to use GPT-5 as the judge, I would actually need to rerun all my evaluations, right? Because who you use as a judge has a huge effect on the evaluation. So you do have to try really hard to keep things constant. So yeah, so that's my approach when I'm considering a new model. And this is using the Azure AI evaluation SDK. I have like a little basically wrapper of it that I use here that has a couple like extra tools that are helpful for me. Mostly like command line tools, right? So it has this tool that shows the summaries, and then like this tools that compares questions, and then it has outputs for markdown and stuff like that. But it's using the Azure AI evaluation SDK in order to do all that. So you can use various SDKs. There's other services for doing that as well. But basically, I recommend is that you have a bunch of questions. Like I have 50 here, but really you should have like 200. Like try and have them be good questions with ideally human generated answers or just well generated ground truth answers based off the whole database that you've vetted those questions. And then you want to rerun your evaluations, keeping everything constant on those new questions whenever something comes out. So what evaluation tool do I recommend? Yeah, PromptFoo is popular with, PromptFoo is in the JavaScript community. It comes from, it's in JavaScript as far as I know. Maybe, I don't know if they ported it to Python. Yeah, I think it looks like it's JavaScript still. So that, I've heard good things about that from my JavaScript colleagues. For Python, we've got the Azure AI Evaluation SDK, and that's the one that I use. And you can do, this one's called Cloud Evaluation, but I do the running evaluations locally, this one. And they've got a bunch of built-in evaluators, but you can also write your own evaluators. So I have some custom evaluators that I've written as well, where you just kind of describe like what a 1 to 5 score would look like and send it out. And you can either save these results locally, or you can push them to AI Foundry and you get little charts there. There's also Deep Eval. That's one that's been around for a while in Python. And then also a lot of like the observability platforms have it baked in, right? So Langfuse, they have evals baked in. So if you are using them for observability, then might as well use their evals too, because it'll be baked in. Arise is another one very similar to Langfuse that has it baked in. Langfuse has a little bit more of an open source angle that you can run it locally, or even run it on Azure using their Docker setup. And let me think, is there anything I'm missing? Oh, or if you're using something like Pedantic, like Insane earlier, I was showing my Pedantic evals. They're still working a lot on their evals. I was actually chatting with them about it last week, but they do, they have evals. So if you're using a framework like Pedantic, LangChain, you can also look to see do they already have it built in? So you have many options. I would just start somewhere, start anywhere, and make sure you set up an automated evaluation flow, because once you've got that set up, it's going to be easier to do, and you'll learn so much from it. Every time I run evals, they're fascinated. I learn something from them, right? So generally you want to run off a lot of data. You want to look at the overall metrics, but you also want to be able to dig in and compare answer to answer and see it. Ideally, you're running it on data that you know. It is really hard to evaluate data that you don't know from a domain you don't know. And as developers, that can be tricky because a lot of times we develop things for domains that we're not an expert in. So it really helps if you can work with some sort of human expert to help you reason about whether the evaluations are correct. Because remember, LLMs are so good at making up convincing answers that you can look at it and be like, oh, okay, great, right? But then a human expert would be like, no, right? So really helps if you do understand the data that you're running it on, or if you can work with somebody who does. Good questions. Okay, so Yeah, okay, so what were we doing? Were we adding? Oh yeah, we were using GitHub Copilot to add something. Okay, so it got all, look at this, it checked all its to-dos, and it now it wants to make sure that the front end can still run. And so that one, it was waiting for me to accept that. So we do have this auto approve if you're in GitHub Copilot and you're like tired of having to auto approve things. Like if you want it to always be okay to do npm run build, you can say like, okay, you can say in the auto approve list, like, hey, it is always okay to do npm run build, right? So it built, so it's happy about that. And it's added various things here. I assume it's got an about page here. There we go. And now it's building a smoke test. That'll be really interesting to see if it does it correctly. Let's see how to try notes, next steps. Only English strings were added. Yeah, it doesn't do localization off the bat a lot. All right, so let's see. So we're gonna try out the changes. My changes usually, this should be auto reloading. So let's see. Okay, good. It auto reloaded. All right. So we can already see the spacing's a little funky, right? So we could just take a screenshot of that and be like, yo, spacing is funky. We can click on that and it looks like it's working. So we can go back here and be like, spacing is funky, right? And then you can just drag in your screenshot and let it figure it out. And boom, send. Okay. So now we can look at that. Is this session being recorded? Yes, it is, because it's on YouTube. I don't really know how LinkedIn works. This is my first time streaming on LinkedIn, but it certainly will be on YouTube under my YouTube channel. But yeah, LinkedIn is pretty cool, actually. I'll probably do some more streams of LinkedIn because it's pretty fun. You all have great question. So let's see. All right, so it's going to make some changes. Okay, so yeah, so what we see, GPT-5 seems like a really good model across the board. I'm probably going to default my GitHub Copilot to use it going forward, because before I was using the Claude Sonnet ones. I was trying to use the GPT-4.1 model because that was the default for a while, but it just wasn't confident enough to actually like do the agentic coding thing. Like it would, a lot of times it would have me, be like, okay, you should do this. I think, no, you're the agent, you do it, right? So GPT-5 seems to be happily actually like taking the actions, right? So it seems like it is a much better agentic coding model that, is going to work for stuff like Copilot. I saw it's in Codex now already. Codex is like the command line coding tool from OpenAI. It's obviously in Cursor because they had Cursor in their announcement, right? So definitely competitive with the Claude models here. Okay, let's see. Did it fix its spacing? Oh. I mean, I don't hate it. I kind of hate it. It's okay. I can just do a screenshot and iterate on it. It's kind of fun though. I think it's not intentional, but now I kind of like it. No, I'll just have it change it. Let's see. So you have another question. Oh yeah, all these code repos. Yeah, all these, everything I've been showing today is under is linked from my GitHub account, my profile page, GitHub/Pamela Fox. So what did we look at? We looked at the LinkedIn agent, ported that to GPT-5. We're looking at the RAG. We looked at the RAG repo. That's the RAG repo that we're adjusting right now. I also, worked off the vision, a vision example. But generally you can find things off my GitHub account. So what type of test do I do to validate whether a model is better than previous models? Do I have a use case wise model preference? That's a good question. So the main thing that I work on is the RAG repo that I've been showing because it is a very popular repo and that you can see like it's been starred and forked a bunch of times and we get lots of requests on it. So this is the main thing I work on. So it's the thing I know the most well is RAG, and so that's what I care the most about, is making sure something works well for RAG. And then also, that it works well for GitHub Copilot because I've used GitHub Copilot quite a bit. So, when I'm validating a model, like I need to validate that it works well for my use cases, and my main use case is RAG. But many other people are really excited about it for, like agentic and tool calling, right? I just don't personally have a ton of actual agents implemented yet where I can really test it out and see how it's doing. But certainly, people with previous models have had a lot of issue with tool calling hallucination, and not strictly adhering to the tool calling schema. Like, these are the tools, these are the arguments, you got to stick with this and not make anything up, and actually do call the tool, right? The other issue, I mean, there's two issues, like, well, there's lots of issues, but like one issue is like it, makes up a tool call that doesn't exist, or makes up an argument that doesn't exist. The other issue is that it just doesn't call the tool at all, and you have to like force it and be like, call the tool, right? And those are like two big issues that people have had with previous models. So I think the hope would be that, if you're doing anything using tool calling, that with GPT-5, we should see that it is better at calling the tools that at the appropriate times and coming up with the right arguments for it. I just don't have a ton of use cases where I'm using a lot of tool calling. I need to build some more like agents for my own personal use so that I can see how well it'll do. But that's why I'm, showing RAG and Vision and GitHub Copilot, because those are my main use cases. All right, cool. So I think we've explored a lot, and I feel like I understand the GPT-5 models a bit more. There's still more to explore. There's this context-free grammar restriction. There's free-form function calling. So certainly check those out if you think they might be useful for you. Like I was talking to someone yesterday who's working like address parsing, right? So this sort of thing might be useful in terms of adhering to, a common, to a grammar for a correct address, right? So yeah, so definitely check out all that, and just share your examples, right? If you have a particular use case and you previously were using a different model for it, and you try all that with GPT-5, just write it all up, share it on a blog, LinkedIn, whatever, because that's what a lot of people are doing this week, and I think it's really helpful to see where models are doing better, where they're maybe doing worse, and what would be really good actually know, like, because right now I'm like actually very impressed by GPT-5, and I think generally it's like better across the board. So it would be good to know if there are some weaknesses, some surprising weaknesses that anyone finds out. So yeah, sharing what you learn. So the citations. Oh, Jack asked, what is the citations part of the RAG app? So the way that it works is, let me go back to here. So the way that citation works is that we have this prompt, and the prompt says that it tells exactly how to include the source. So here, let me put this on more lines so you can read it. Okay, so we describe the sources. So each source has a name, name followed by colon. Use square brackets to reference each source. Don't combine sources, right? So we're very, very specific about how to do citations. And then when we get back the responses, they have that format, right? You can't really see it here because at this point I've already turned it into HTML. But in fact, this 1, 2, 3 was actually in square brackets, and I extracted it, right? So that's something that's really important to me when I'm evaluating a model. When I'm looking at RAG, like the model has to both have a good answer, but it also has to be able to provide a citation in the appropriate format and not make up any citations. So that's why I have a particular metric that looks at citation match in regex, and that metric is actually it is a custom metric, right? And it's literally it's a regular expression, right? So I have my ground truth, right? So here's my ground truth. Let me put this on another line so you can see. Okay, so right in my ground truth, I'll have a citation inside square brackets. So this is the format that we expect. And so then when this is the ground truth, this is like the perfect answer with the perfect citation. That's the idea of ground truth. And so then when we get back a new response from the app that's, using a new model, a new prompt, then we look at the ground truth citations, we look at the response citations, and we check to see which percentage of the ground truth citations are also in the response. So this is my regular expression-based metric, which is actually one of my favorite metrics because citations are so important. And, generally the right answer should be referring to the correct citation. So so that's how we get it back. And then in the user interface, we extract them, turn them into clickable links. Let's see if this loads. It looks like it's loading. Yeah, sometimes it can be a little slow, but there we go. So it jumped to here. Now when we look at this, we can actually see that this one was a hallucinated answer because it says senior manager, product manager, and doesn't say what a product manager is. And that's why it's really important to have citations so that the user can look and see like, oh, wait a second, like none of these are actually, actual product manager. These are just other kinds of managers, right? So it's just being really specific in that format and then extracting that, getting that back out, turning it to UI and making it so that we can open the PDFs inside the browser. And then do I have prompt? So why do I use Prompty? Any other tools for prompt management? Okay, so I am using Prompty here. This is my first repo experimenting with Prompty. So Prompty is a format for prompt management. The idea is that you have metadata up here, which describes the prompt, has a little sample here, and then you have the actual prompt, which is a Jinja template. So if you're from the Python community, you might know Jinja. It's a templating language. So we can do ifs and else and fors and all that sort of thing, right? So it's nice. I'm happy to just have the prompt outside of my Python code, right? Because it's a lot of natural language. It was really awkward when it was just inside my Python code as like a multi-line string. So I'm happy to have it in a separate file. It feels more manageable. As for other prompt formats, there's lots. And there's another one that I have because of GitHub. So GitHub has their own prompt format, which is kind of similar. So here you can see this is the GitHub model prompt format. So you do .prompt.yaml, and it's really similar, except that the message is also inside the YAML. So this one's full on, this is a full on YAML file, right? So we can have the description, the messages, and then if we go here to models, then we can actually try out the prompt, right? So it actually finds the prompt inside the repo, and then we can test it using GitHub models. So we can do this and, puts everything in here and be like, okay, how do for loops work? Or I fix my for loop for I in var equals 10. That's a horrible. So then we can go and run that. Okay, so that's nice. If you use the GitHub prompt format, then you'll automatically be able to just test it from the GitHub repo, which is pretty cool. So let me get the information about the GitHub models prompt format. So those are the only ones I've used so far because those are the ones in the kind of Microsoft ecosystem. There's also, I guess there's a GH prompt. I don't even know that one. So I'm sure everyone's experimenting with prompt formats. I think it's just good to try and get it out of your code, but it does depend. If you're doing a lot of agentic stuff, then a lot of times like the prompt is really like your doc string for your function, right? If you're using an agentic framework where you just define your tools using functions. So in that case, it might feel awkward to pull that out into its own spot, right? So yeah, developing with LLMs is really weird because it's like we have this mix of natural language and structure, right? So for example, like the one that uses a tool, query rewrite tool. Okay, so this is the one that rewrites the search query, and this one I say, oh, you're going to use this tool, right? And then I put the tool in the separate file as a JSON schema. So that's one approach to tools, but there's also a whole other approach where I could just write this as like a Python function and be like def search sources and that takes search query, and here's the annotation. It's a string, and then it's got like a doc string, and that's kind of nice, right? So if you're doing agentic stuff, I feel like you actually do want to just define them as functions, inside your code base and not necessarily have the prompt outside. So I think it's nice to, if it's have a big old long system prompt like this, then I think it's nice to use promptd or prompt.yaml or even just a text file. Like another repo I have, I think I'm still just using, just a separate text file. Prompts. Yeah, so these are just straight up text files, right? But I was still happy to get it outside of the code because then we can iterate on separately. Oh, we see John was the most recent one to iterate on this one. So I think if it's long, if it's like an overall system prompt or developer prompt, whatever you want to call it now, then I think it is nice to get it out of your code base, whatever format you choose to use. But if you are doing something highly agentic with lots of tools, then I would probably define them as Python tools and keep everything just inside the Python. Let's see. Oh, I see some chatter. Okay. Thank you, Jack. All right, let's see. If I have a deep research agent, how can I make it search for the same thing while changing one parameter? I haven't messed with it. Do you mean using the OpenAI deep research or like the Copilot deep research? Or are you implemented yourself? Like, how are you doing your deep research? Search for the same thing while changing one parameter like the city. Yeah, this is a good question. Okay. All right. So like an agent I built. Okay, so let me think through this. I haven't done a deep research. The only deep research I've done so far is just using the Copilot, like Teams Copilot, the deep research agent. And I was pretty impressed. It was pretty cool. I haven't done anything else deep research. I think I did actually get access to it now. So I think if I went here, so I think when I asked for GPT-5 access, I did actually get deep research. Let's see, can I do it now? I can. All right, deploy. Oh, insufficient quota. Dang it. I'm not in a good location. All right, I got permission, but I don't have enough quota. Okay, so close. All right. So I don't know. I have to write a deep research agent and see. You maybe you'll have some caching or something. Yeah, I don't know. It's a good question. I think I'm out of my depth on that one. Oh, okay. You've got a LangChain repo. Okay. All right. Let me check it out. Good. I want to do more with LangChain. I'm going to LangChain meetup next week about multi-agents. So might learn some stuff on that one. LangChain's making some good repos, really helpful repos. I have like a list of ones I want to do. Okay. So open deep research. So we have, let me paste this here. So we get the request. Dun, dun, dun. I guess the question is, if you're researching the same thing but a different city, how many of the things, like, is there actually an overlap in the things that it's looking for, right? Because a different city might be just completely different stuff. Because that's actually, when I did deep research, I had it research the restaurant industry in Syracuse, New York, right? And so it did like a web search and it found all these things about Syracuse, New York, restaurants, etc. And none of the search results, which actually would have been the same if I had changed that to a different city. I think you will get token caching just from the system prompts, right? But I feel like you still want to do the search. What you could do is just kind of like you could have like maybe like a tool which was like, retrieve past results, and you could let it know like, hey, that give it access to that tool so that if there was like a past search result that it already got, it could get access to that so that you didn't have to re-parse the page, kind of like caching the search results. So I would maybe try something like that. Oh, these ones all, wait, results, GP5. Oh, they just tried GP5. Nice. Yeah. Yeah, those are my immediate thoughts. I don't have a really good idea without actually trying this out and testing it. Oh, the volume. Okay. So if it's 5 cities, it might work well, but if it's 100, it's another story. Yeah, the question is though, is the time being spent on, what, like, you kind of have to look and see like what is common across 100 cities, right? Like, are there common search results that it's getting for each of them that you could, cache and basically say like, oh, you already have access to it? Like, um, I don't know because it depends on what it is you're actually searching for. I think you'd have to like run it and see what is common. Nothing is common. Nothing is common. Well, then I'm not sure what to do. I don't know. Yeah, I mean, I think if nothing's common, I think you'll get some token caching from system prompt stuff, and that can help. They did say with GPT-5 that you can, it'll remember its chain of thought. So maybe if you are doing this GPT-5, but then you would have to do it sequentially, right? Because the whole idea with GPT-5 is that if you use it with the responses API, like the chain of thought will continue from one to the next and next, which could help for that if it does have a chain of thought. But that means that you can't run it in parallel, right? Which is a performance thing. Because in theory, if they're truly independent and there's no sort of like things that should be cached between them, then you could run those 100 in parallel and then like you just need a high amount of capacity, but at least they're running in parallel. But on the other hand, if it feels like they could build on each other, then you'd want to run in sequence and maybe have it one for the next, or kind of a mix. You could do the initial search for one, and maybe there's a few things that are relevant from that that you keep, but then you run the rest of them in parallel, right? Cool. Okay. And then from Jack, share the cadence of these live streams. Do I have any Discord and community? So we do have, I do weekly office hours on the Discord. This is the Azure AI Discord. So definitely come to weekly office hours. It's every Thursday. And yeah, I know for live streams, you're supposed to like be regular, and I haven't been very good at being regular. So um, I can try to be regular, but I haven't come up with a great regular time yet. So right now, the live streams are just when I feel like it. But I know that the best practice is to be regular, and I'll try to do that. Usually, it's just whatever seems super fun. All right, so final verdict on DB5. I'm impressed. I know other people weren't impressed because I guess people were waiting for AGI. I'm not waiting for AGI. I don't, that's kind of scary, actually. I'd rather not have AGI. I need a model that can practically be used for RAG and tool calling and structured outputs, right? And the model's very good. It's very fast. I'm the only thing I'm unhappy about is the current like capacity constraints we seem to be having with the full GPT-5 model. But to be honest, GPT-5 mini seems like it's all you need, right? Like I need to run some more evaluation to see whether the full GPT-5 is actually substantially better and worth it. But GPT-5 mini has really impressed me. It's like seems fundamentally different in the way that they trained it to reduce hallucinations, which is really exciting because that's been such a big issue. So I'm on board with it. It's a big practical improvement, and I think it's going to be the go-to model for a lot of our tasks going forward. Steve is using Promptlify. That's another one. I don't even know Promptlify. All right, AI prompt management. Oh, it's a whole platform. Well, that makes sense. Amplify your AI potential. Open source AI management platform. And you have an external prompt repo. Nice. Yeah, I should start doing that for like the GitHub prompts that I'm working on, right? Because I'm starting to add more prompts. Like we have the awesome Copilot repo that has a bunch of prompts for GitHub Copilot. And I've started working on more of these prompts, and it would be good to be able to optimize them. So that's cool.
Justin says, way better at coding than VS Code. Claude is competition now. Oh, that's cool. I'm just gonna screenshot that, send it to the VS Code team. They'll be happy. All right, okay. I should go now. It's been almost 2 hours and I have to actually clean my house very quickly. But this is really fun. So definitely do this again, stream to LinkedIn, and loved all the questions and exploration, and looking forward to seeing you next time, whenever it may be. Bye, everyone.